when we were covering, yes, it was last session, when we were covering big GANs, we mentioned self-attention GANs. The video is online, so I'm not going to spend too much time on it. But what is the idea here? We are going to be introducing attention to GANs. And it's the type of attention that we are using for natural language and transformer architectures. And the idea is you're going to take the feature maps coming out of some layer in your deep neural network. So these are featureized images. And then you do some one-by-one convolution on them. You take F, you transpose it. Literally, you're transposing. You multiply F by G. These are going to give you, to the extent that a model is attending to the ith location of your image when generating the jth location. And that's exactly these attentions. How much are you paying attention to other regions of your image while predicting or generating this portion of the image? This is your attention map. You pay attention, query key value, and then this is just a linear combination of those attention weights, and where it's a linear combination of these value vectors where the coefficients are coming from your attention map. And then you can output and go to the next layer. This is happening at the coarser layers of your neural network. You cannot do it you can, but it's going to end up being super costly because each pixel needs to pay attention to another pixel or every other pixel. That's going to end up being costly. So you're going to do it at coarser levels, the first few layers of your architecture. And remember, now you're going backward. You go from coarse layer to high resolution. Unlike classification type of networks where you go from high resolution to low resolution, here you are going backward because you're generating images. Your output is an image. We are going to be using hinge loss, and then we learned about these techniques. That's why we were covering them. We learned about the spectral normalization and 2-time scale update rule, and we also learned about our evaluation metrics. And then you can inject spectral normalization, not only on your discriminator, but also on your generator. And then it also helps if you use the 2-time scale update rule. Any questions about self-attention GANs? Was everything clear? Okay, perfect.